Hi everyone. It's so exciting to be here to see this event that's being put on. It's such an exciting space. Um, for those of you that I haven't met before, I do see a couple of familiar faces. My name is Dr. Nichola Conlon, and I am a scientist and I specialize in the science of cellular aging. So what is it that is going on inside of our cells to cause the aging process that we see going on the outside? And we've just spoken a lot about drugs in that previous presentation, and my background is actually in drug development. So I was very fortunate enough to work for some companies that were very forward thinking, that started looking at developing drugs to slow aging nearly a decade ago now. Yeah. But actually, I am not in the drug development industry anymore. I actually left in 2017 and I founded my own company, which is called Nichola Laboratories. And that was for one major reason, in that I could see that there was all this fantastic science happening around the space of longevity. And actually, many of the molecules that we were researching that seemed to work really well when it came to cellular aging were not your classic drug molecules. They were not molecules that drugs companies could patent and own, and therefore they weren't getting the research that I felt that they deserved. They were more natural molecules. So I set up Nichola Laboratories, and our mission was basically, let's take some of these molecules that aren't your typical drug molecules, give them the research that they deserve, and basically try to get some of this science into the hands of people and consumers much quicker. So our mission is basically to translate the latest science in the field of aging into consumer products that people can actually start benefiting from now, until we are, in the future in a position where we will have such drugs that have just been spoken about. So I think everyone here knows that it's just such an exciting time to be involved in anything to do with aging and longevity. It seems now that a day doesn't go by where we don't have some big headline or some new paper being published to show us that we really can slow aging on a cellular level, and actually a lot more evidence now that we can even reverse some of the signs of cellular aging. So it's just incredibly exciting to be involved in this space. And there are many different things and many different ways that we can target the hallmarks of aging. But for this talk today, I'm just going to concentrate on one thing. And that thing is NAD. I'm sure that many of you guys will have heard of NAD, but if you hadn't, it actually stands for nicotinamide adenine dinucleotide. That is a bit of a mouthful, which is why we abbreviate it. You don't need to remember that, you just need to remember NAD. And what is it? Well, it's a natural molecule, and it's actually found in every single cell in your body. And it's involved in hundreds of different reactions, but it's actually most famous for two. And the two things that it's most famous for are, firstly, energy production in our mitochondria. It basically helps in the process that takes all the food that we eat and converts it into the energy that our cells need to function. The second thing that it's very important for is maintenance and repair in the cells. It activates a lot of repair processes to keep our cells in good health. So as a general rule of thumb, all you need to know is that if you have high NAD, you seem to get lots of repair and lots of energy production. And if you have low NAD, then repair and energy production gets turned down. Now, one of the reasons why NAD seems to influence so many important repair and maintenance pathways is it actually works alongside a group of longevity proteins called the sirtuins. Now, these sirtuins are actually able to switch on many beneficial processes and pathways in the cells that are associated with good cellular health. And the link between NAD and the sirtuins is that NAD basically acts as a fuel for these the sort of enzymes, and it powers them. So if you have low NAD, then the sirtuins will not be able to work. They absolutely depend on NAD. Now, the reason NAD has actually been associated with aging and has a lot of interest within the longevity space is it's actually found to decline with age. And this actually declines quite a lot. It's estimated to decline by around 50% every 20 years. The reason I always show a bit of a bumpy graph is it goes down in everyone, but actually lifestyle is a big factor as well. It can really impact your levels. But this is an issue because when it goes down, what that means is that you don't have enough NAD to power the sirtuins for repair. You get inefficient energy production. You start to get damage accumulating in the cells. And this manifests as a lot of the signs and symptoms that we associate with cellular aging. So probably, way over a decade ago now, scientists said, well, if we've got this important molecule and it's keeping all these beneficial processes switched on, but it goes down with age, then why don't we just not let it go down with age? Why don't we try and keep it topped up, or actually just, get it back up to youthful levels, or not even let it decline at all? And to cut a very long story short, there's now been hundreds, if not thousands, of experiments now from in cells to animals, and now emerging a lot more in humans, to show that NAD seems to have a big benefit in improving all-round cellular health or health span. It kind of seems to tick every box. Everything from improved cellular energy to better DNA repair, improved cardiovascular function, neurological function. It seems to tick a lot of boxes. But again, if you think about it, it's not really surprising because NAD is found in every single cell. And it's very important in every single cell. So when it declines, that is a big issue. But when you top it back up again, it's also going to have multiple benefits. So a key question has been, well, how do you boost NAD? And there's been a lot of debate in this space. First of all, it was thought, well, if this NAD molecule's gone down, then we'll just top it up. Why don't we just put it in IVs, put it in capsules, put it in injections, any way we can to get it back into the body? Well, unfortunately, it's not as simple as that for a couple of reasons. The first reason is that NAD is actually a really unstable molecule. It breaks down very easily, so you can't just think that you can swallow it and it's somehow going to get into your cells. It's also a large molecule, if you look at the structure, and cells generally don't like to let things just pass in and out. Big molecules usually need some sort of transporter, and that means that NAD cannot get into many cells in its whole form. So this is where precursors came about. Now, these are something you may have heard of, precursors such as NR or NMN. What these are basically the raw materials that the body uses to make NAD. So the idea behind this was that, okay, if NAD itself is too big, why don't we give the body more of the raw material that it needs to just make more NAD? But the issue with precursors that we're now finding is actually they are not actually fixing the reason why NAD is declining. And there's now emerging evidence that they may actually be causing some other problems with methylation and also driving inflammation in some of the studies that have recently come out. So what's the best way to try and boost NAD that's sort of based on the latest science, and what is actually causing this NAD decline? Because for a long time, we didn't really know why NAD was actually going down, but now we do. So in order to explain why it's actually going down, first of all, you need to understand how your cells actually make NAD when they are young. So we know that in healthy young cells, actually, the majority of our NAD is recycled. Our cells are actually incredibly good at making NAD. Basically, what happens is if you have NAD and it's used up in cellular repair by the sirtuins, things like that, it's broken down into a precursor called nicotinamide, and then this pathway called the salvage pathway literally scoops the nicotinamide back up and recycles it straight back round into NAD again. And this is quite clever in the cell because what it means is that as the use of NAD goes up, production also goes up. So it's like a really clever way of making sure your NAD levels are regulated. Now, the issue is that this becomes dysfunctional as we get older. What we now know is that one of the main reasons for NAD decline is because a key enzyme in this pathway, this one here called NAMPT, actually declines with age. And that's a big issue because that means when NAD is used, it's broken down, and this nicotinamide simply can't be recycled back into fresh NAD again, so you start to get a deficit. And this actually goes on to cause some further problems because what happens is if this nicotinamide can't be recycled, it starts to build up in the cell. And cells do not like it when things start to build up. They like homeostasis. They like to regulate things. So the cell responds by going, oh my goodness, right, we've got all this nicotinamide building up. We're going to have to get rid of it. So it upregulates another enzyme here called NNMT. And that's a methylating enzyme. And what that does is it basically sticks a methyl group on this nicotinamide to create methyl nicotinamide, which signals it to be excreted from the cell. Now, methyl groups are actually really important for a lot of things. This is not what they should be getting used for. They should be getting used for things like epigenetics, DNA repair. But when we start to have this dysfunction, they start getting wasted on trying to get rid of this nicotinamide. Another main reason that we now know of why NAD actually declines is chronic inflammation. We know chronic inflammation is one of the hallmarks of aging. And what happens is a lot of this inflammatory junk that seems to be in our bodies increases expression of an inflammatory enzyme called CD38, which can be seen at the bottom here. Now, CD38 is a prolific user of NAD, okay? It uses NAD as a fuel, just like the sirtuins do. But just to put it into perspective of how much it uses, for every one cycle of this enzyme, it uses 100 molecules of NAD, as opposed to the sirtuins, which use about 3 or 4. So it wastes a lot of NAD. And what happens is just as when the NAD is being used by CD38, it's still broken down into nicotinamide. So again, you're getting huge amounts of nicotinamide building up. This has to be methylated and excreted, resulting in even more loss of these important methyl groups. So you can kind of see there's a lot going on. We now have a much better understanding of why NAD is declining. And bearing all that in mind, now let's look at what happens when you try to fix this by using a precursor, such as NR or NMN. You can see that the precursors, may boost NAD. There is some evidence that they do that. But there's some issues, which I mentioned before. You may be inadvertently driving inflammation if you are not making sure that this CD38 is inhibited. CD38 actually has a much higher affinity for NAD than any of the DNA repair enzymes or the sirtuins or any of the beneficial pathways where you want NAD to go. And what I mean by a higher affinity is it means that if there is NAD in the cell, this CD38 will grab onto it and use it before any of the beneficial repair processes even get a look in. So this is why we think we're seeing some issues with inflammation with things like NMN. The other issue is if you are trying to boost NAD without fixing this salvage pathway, that NAD that you do increase will be used once and then it can't be recycled and it's going to have to be methylated and excreted. And this is again what we see. So in some of the human studies with NR, we see that as the amount of the dose of NR is increased, it doesn't equal an increase in NAD. NAD actually plateaus, but methyl nicotinamide just keeps going up, 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 up as the body struggles to actually deal with it. So when we founded the company, NAD was one of the things we wanted to focus on because we could see that a lot of the products and things that were out there were not really making sense when you looked at the science. So basically, we designed a different supplement that works entirely differently. And what we were looking to do is basically address all of these root causes of NAD decline. So we wanted to switch back on that NAMPT enzyme so that salvage pathway was working better again. We wanted to inhibit that inflammatory CD38 so that wasn't unnecessarily wasting NAD, and also promote recycling rather than excretion of the nicotinamide and wasting these methyl groups. So, as I mentioned, my background is in drug development, and everyone thought I was a little bit crazy when I left that very reputable job to have a supplement company. But my vision was that we wanted to bring out things that actually have some good clinical testing and science behind them, so we did a clinical trial. So this was a double-blinded, placebo-controlled crossover study, so a gold standard in terms of design. It was 28 people. Our participants were actually aged between 20 to 80, and there were also male and female, which is very unusual for a clinical study. All the studies for NAD have been done in sort of 55 to 65-year-old men, which I'm pretty sure you'll agree is not very representative. So we did it a bit differently. So what did we actually look at? Well, first of all, we wanted to check NAD. So it boosts NAD. So that was good. We also wanted to look at how quickly it boosts NAD. Is this, how soon are we seeing the effects? And we saw a significant increase in NAD in the blood after just 7 days. The key thing for us was, though, yes, we're boosting NAD, but are we actually fixing a root cause of NAD decline? Are we actually switching back on the NAMPT enzyme that is so crucial for NAD production in our cells? And you can see here that compared to placebo, we are actually increasing levels of the enzyme in the cells of these participants. And this is the first human study to actually demonstrate that a supplement can actually fix a root cause of NAD decline. We also looked at levels of the sirtuins, these longevity proteins that are very critical for switching on a lot of cellular health pathways, and saw an increased level of those as well. And also what we wanted to do is check that we weren't driving inflammation. Was this NAD going to beneficial pathways and not to CD38? Because one of the components of the supplement is a CD38 inhibitor. And you can see that we did actually significantly reduce some inflammatory cytokines. So for us, again, that shows that it is actually helping to fix some of the root causes of this decline. We also looked at glycation. Glycation is an important factor in aging. It's where sugar molecules become irreversibly bind to proteins. It's a huge problem in things like skin aging and also stiffening of the arteries. And again, we can see that that actually went down as well. So that was good. But I guess most exciting for me was that we actually saw a reduction in biological age. And I don't need to explain this because Nina's already done it. We used the GlycanAge kit and saw that in just 28 days, we saw on average a reduction in biological age by 1.26 years. So again, it's showing that this the increase in NAD that we're seeing is actually going to improving the health of our body and our cells. So just to finish off, people say, well, it's fair enough measuring all these biomarkers and things like that, but the top question that I always get asked is, how does this relate to something clinical? So we do want to do more clinical studies in the future, but just some feedback from customers in that the top reported things that we see are, first of all, an improvement in physical energy and also cognitive function, so mental energy. And again, this makes perfect sense because NAD is so critical for energy production. The other thing that we see is a huge benefit in people's sleep. And one thing that's not talked about very much is the fact that NAD is very important in regulating circadian rhythm. And a decrease in NAD can cause some problems in this as you get older. And then, with continued use, you see the improvements in the outside, like your hair, skin, and nails. I generally don't get as excited about them, but lots of people do. And, if your cells are in good health on the inside, then that is also going to show on the outside. So thank you so much.